Before we delve into Einsteinian special relativity, it's very useful to have a background knowledge about Galilean transformations. Galileo is the founder of kinematics. He believed that space and time were absolute. Galilean transformations means how to analyze the speed and distance from one reference frame to the other. Here I have a ground observer at rest and a car moving rightward. There is a target point like a tree 20 meters away from both. The car is traveling at constant speed of 2 meters per second. After 3 seconds, we expect the car travel for 6 meters, okay? Because in every second it travels for 2 meters, so after 3 seconds, we expect 6 meters away. So the remaining distance from the car to the tree is 20 minus 6, so it's 14. In general, we can assume that the person has a distance x to the tree. The distance traveled by the car is vt, and so the remaining distance is x minus vt. When it comes to relativistic case, it is not that easy. In future, we will develop that according to Einsteinian postulates. What do we mean by that? Basically, here we believe that the person and the driver of the car both agree on this 14 meter, for example. Okay? But in Einsteinian relativity, when the car is moving really fast, let's say 0.8 c, it's not that easy. The person may measure the distance between the car and the tree for 14 meters, but the driver of the car won't agree. We will learn it in future. What about the velocity? Here I have a big boy at rest relative to the ground, small boy in red moving at a speed of 1 meter per second rightward, and at the same time honeybee moving at a speed of 4 meters per second rightward. What's the velocity of honeybee relative to a small boy? In 1 second, the honeybee will travel for 4 meters, and the same time, small boy for 1 meter. So change in distance, relative distance between the small boy and the honeybee will be 3 meters. So the velocity of honeybee relative to small boy will be 3 meters per second rightward. At the same time, honeybee believes that small boy is moving backward at a speed of negative 3 meters per second. Galilean relativity and Newton's postulates. Galileo and Newton, are founders of classical mechanics. They believe that when an object is moving with a constant velocity in one reference frame, then it will also have a constant but possibly different velocity in other reference frame. Another example. A bus moves at a constant velocity of 8 meters per second relative to the ground. This is the bus. A boy on the bus walks toward the rear of the bus at a constant velocity of 1.5 meters per second. It's moving at a speed of 1.5 meters per second leftward on the bus, relative to the bus. Calculate the velocity of the boy relative to the ground. It's very easy. In 1 second, the bus will displace for 8 meters rightward. At the same time, the boy goes back for 1.5 meters. So the net distance traveled by the boy relative to the ground will be 6.5 meters, 8 minus 1.5. So the net speed of the boy relative to the ground is 6.5 meters per second. This is Galilean transformation. Let's say we are in relativity. So it's 0.8 c, for example. This is 0.15 c. And then you may expect, it's going to be 0.65 c, but it's not correct. We will learn it in relativity. It's not that easy because the space and time will become relative. And so it's not an easy approach like that, like the Galilean transformations to find the relative speed. We will learn it. The distance walked by the boy relative to the bus is 3 meters. 3 meters means that probably it has passed for 1 plus 1 second. Each second takes 1.5 meter displacement for the boy on the bus. So it's 2 seconds probably. Calculate the distance traveled during the same time by the boy relative to the ground. Okay. Here in 1 second, the boy goes 1.5 meter leftward. So in 2 seconds, 3 meters. At the same time, the bus will travel for 2 times 8 meters in 2 seconds. So it's 16 meters. It's the net displacement of the bus. But as the boy is traveling at a net speed of 6.5 meters per second relative to the ground, His displacement relative to the ground in 2 seconds will be 13 meters rightward. That's very easy. So we learned what the Galilean transformation is. Let's proceed to see what's going on next. Thank you for watching this video.